Alright, what I have here is a system of equations, and as you may know already, a system of equations is when you have two or more equations that are both true at the same time. So in this case, we're told that y is 3x minus 2 and 5x minus 3y is negative 10. So we have to figure out what two values for x and y will make both of these equations work. Now, of course, we could make either one of these equations work with an infinite number of values for x and y. Suppose x is going to be 2. Alright, we've got y is going to be 3 times 2, which is 6, minus 2 is 4. If x is 5, y is going to be 15 minus 2, or 13. So we have an infinite number of solutions to this equation, the same way we have an infinite number of solutions to this equation. But what we have to do here is figure out a way to make both of these solutions work at the same time. Chances are there's only going to be one way to do that. So let's get started. This method that we're going to use today is called substitution. In this case, y is already isolated, and that doesn't really tell us much. It just tells us the value of y in terms of x. But it turns out that that's very valuable because we can take this right here. This expression is equal to y, and we can just plug it in for y in this other equation, giving us 5x minus 3 times 3x minus 2 equals negative 10. And then we can distribute this 3, giving us 5x minus 9x, because this is a negative 3 here that we're distributing, so negative 3 times 3x is 9x, and then negative 3 times negative 2 is positive 6, so plus 6, and we've got 5x minus 9x is negative 4x, plus 6 equals negative 10. Now we can just subtract 6 from both sides, giving us negative 4x equals negative 16. Divide both sides by negative 4, and we get x equals positive 4. Alright, now that we know x equals positive 4, we can just plug that in for x in either of these equations. I'm going to take this one since we've already solved for y. 3 times 4 minus 2 is y, right? Because y is 3x minus 2. If x is 4, then y is 3 times 4 minus 2. And that just gives us 12 minus 2, or 10 for y. So our solution is 4, 10. 4 represents x, 10 represents y. That's it. Now, it's not always going to be this easy. In this case, the substitution method was really easy because we already had y isolated for us. But that's okay, even if it's not. Let's look at an example of a situation where y is not isolated for us. 3x plus 4y equals 15, and 2x minus 6y equals negative 4. Alright, so we're going to have a system of equations where both of these have to be true. We're going to try to solve this using the substitution method. The key to solving a system of equations by substitution is to have a variable isolated. In this case, neither x nor y is isolated, so we can't actually solve this by substitution. But we know how to isolate a variable, right? It's just basically solving a literal equation is one way to think about it. Let's take 2x minus 6y equals negative 4, and let's isolate the x. So we're going to add 6y. We get 2x minus 6y plus 6y equals negative 4 plus 6y. And then we'll just divide everything by 2. X equals negative 2 plus 3y. Alright, there we go. So now we can solve this by substitution just by taking this value right here and substituting it for x into this equation right here. So that'll give us 3 times x, I'll put a parenthesis here to represent whatever x is, plus 4 times y equals 15. And we know that x is equal to negative 2 plus 3y, so negative 2 plus 3y goes in the parentheses, and we just distribute. 3 times negative 2 is negative 6, 3 times 3y is 9y, so we get negative 6 plus 9y plus 4y equals 15. Now, 9 and 4 are 13, of course, so we've got 13y minus 6 equals 15. And add 6 to both sides, we get 13y equals 21. And we can divide both sides by 13. I'm going to do it up here now. Y equals 21 over 13. And now we can just go ahead and substitute that into this equation right here. We know that x is negative 2 plus 3y. So if y is 21 over 13, x is going to be negative 2. Sorry, x equals negative 2 plus 3 times, what y is, which is 21 over 13. So x is negative 2 plus 3 times 21 is 63 over 13. And negative 2, of course, can be rewritten as negative 26 over 13 plus 63 over 13. So x is 63 minus 26 over 13, or 37 over 13. So that's our value for x. And we can write our solution up here. I'll just put it here since there's lots of space, as 37 over 13, 21 over 13. And that's our solution right there. All right, now we can check our work, because checking work is always good to do, by plugging these values into the original equations. So in this case, we've got 3 times 37 over 13, which is 111 over 13. Right, 3 times 37 is 111. So that's 3x, plus 4 times y is going to be 84 over 13, equals 15. Now 111 plus 84 is going to be 195 over 13, equals 15. So that checks out. If we want to be extra cautious, we can check the other equation too. It's usually good to check both equations, because sometimes if you mess up, you'll mess it up in a way that makes one of the equations true, but the other one false. 2x minus 6y is negative 4. 2 times 37 over 13, which is 74 over 13, minus 6 times 21 is 126 over 13, equals negative 4. All right, now 74 minus 126 is negative 52. So we've got negative 52 over 13 is negative 4. And if we divide 52 by 13, that checks out. So now we know that our solution is true because it works for both equations. All right, so that's substitution. Thanks.